All right. Well, I guess I thought it was gonna be 4 videos, but I guess it might be more. Um, I decided I'm going to split this up into 2 parts. Um, okay, so we'll just call this part 1, I guess. Okay. If you want to skip to part 2, that part 2 is gonna be the examples we did in class. This one is more the examples that I showed very briefly on the board. Okay. So this is on applying properties of similar figures. So up here, yeah, so there's some properties of similar figures. So based on what I went over in section 11.1, which is dilations, we said that certain sides are going to be proportional to each other, and we know that the corresponding angles of similar figures are going to be congruent. So angle A is going to be congruent to angle X, angle B is going to be congruent to angle Y, angle C is going to be congruent to angle Z, and the sides are going to be proportional to each other. Okay, so first what I'm going to do is I'm going to show you some examples of how you can apply this. Okay, so this first part here, are the triangles similar to each other? So I'll just ignore the part on the bottom. Okay. Okay, so are these triangles similar to each other? So what you want to do is you want to compare the ratios of all these sides. Okay, so one way to write this out, AB over XY equals BC divided by YZ equals AC divided by XC. You want to check all of these proportions, and if all these proportions are equal, that means the triangles are similar to each other. If one falls out of proportion, that means the triangles are not similar to each other. Okay, so let's go and calculate this. So AB is 4, XY is 16, BC is 6, YZ is 24, AC is 3, XZ is 12. So if you had to go ahead and calculate all these ratios, they all reduce down to 1/4. So since they're all 1/4 or 0.25, these triangles are indeed similar to each other. Okay. Let's go over the next example. So this next example I have for you, are these triangles similar to each other? Okay. So just by looking at it, no. Because if you look at this, one way to visualize it, 5 times 3 is 15, 4 times 3 is 12, 2 times 4 is 8. So they're not going to be similar to each other. The other way that you could do this, though, is I'm just going to do it the very long way. So PQ divided by TS or ST. It doesn't matter. I'm just going to try to be consistent. ST equals QR divided by TU equals PR divided by SU. So you want to check all of these proportions and see if they are equal to each other. Okay, so if I were to calculate all these proportions, so this is 2 divided by 8 equals 5 divided by 15 equals 4 divided by 12. So here, if we reduce this fraction and this fraction here, this reduces down to 1/3. However, if I reduce this fraction down, this is 1/4. Is 1/4 the same as 1/3? No. So PQ and ST, they fall out of proportion compared to the other sides. So therefore, these triangles are not similar to each other. So if we want to be picky, okay, this is no, yeah. And this one here is yes. Okay. Yeah. Okay. So I have one more example. So this is my last example that I have for you. Okay, so are these triangles similar to each other? And if they are, how would we write the triangle similarity statement? Okay, so if we went ahead and tried to figure out if these triangles are similar to each other, this part is just, yeah, so PQ divided by ST equals QR divided by TU, PR divided by SU. So if you had to go and solve it through, This is 3 over 6 equals 5 divided by 10 equals 4 divided by 8. All of these proportions, they end up being 1/2. So if they're all proportional to each other, they are similar. So this is yes. Okay. So if they are, how will we write the triangle similarity statement? Okay, so the triangle similarity statement is just like how we wrote the congruent statement. It has to follow a specific order. So we have here, we have triangle PQR. If you didn't catch this earlier, this tilde means is similar to. So this means triangle PQR is going to be similar to triangle STU. So yeah, it just has to follow that same order. Okay. All right. Actually, this is actually a pretty good overview into section 11.4. So 11.4 is on side similarity. If you look at all of these examples that we've gone over, these are all examples of proving if triangles are similar by side similarity. Okay, but I just wanted to introduce this now because there's quite a bit of overlap with these sections. Okay, this is part 1 and that is it. I'm going to go over part 2. Part 2 is the example problems that we worked over in class.